Assalamualaikum and very good morning. So another example regarding the increment where you need to apply the total differential is based on this example. Okay, so we have a problem here where we have a rectangular blocks of wood. So the measurement of that block. Okay, so imagine now you have a rectangle blocks. Okay, you have a blocks. So block wood found to be 100 millimeter. So let's say the width is 100 millimeter and the length is 120 and the height is 200. They are all in the same unit. Okay, possible error of 5 millimeter in each measurement. So let's say I just put the length is x and then the width is x, the length is y. So this is x, this is y, and this is z. And z is the height. Okay, so as provided we have 100, this one 120, and this one 200, and the error of each of the measurement, this y, this z, is 5. Because we have the same unit, so I don't put the unit because we know that they are all millimeters. Okay, find approximately. So you have to, when there is a word approximate, meaning you can use total differential. The greatest error in the surface area. So they're asking for surface area of this block, rectangular block. So what is the question about? Maximum error. So remember last time, okay, so from the notes that I give you, I list you some of the type of approximation. So the maximum error. So you have to put the absolute sign. Okay, so now we want to implement this formula. First, you have to you have to obtain the total differential, and at the same time you have to put the absolute sign because there is a word maximum error in the surface area of the block. Okay, so we want to get the greatest means the maximum error of surface area. Okay, surface area of the block, surface area. Okay, so in this case, if they're asking for volume, find the maximum error of the volume of the cone, for example, then you have to obtain the formula. You have to find the function or the equation of the volume. Now they ask you about the surface area. So you have to obtain the equation of the surface area of this particular solid, which is you have a cuboid, right? Okay, so what is the formula? So let's say I put S. So what is the formula to obtain the surface area? It is not given. So you have to find it yourself. Okay. Alright, so how many surfaces there? You got 6 surfaces, right? So we have something the floor down here. So how can we get the surface area? The area of this surface, this particular surface, only this one, only this area. So you can have just xy. So that is only that surface. The size of this surface is equal to this surface, right? So you got 2. So 2 multiplied by xy. So that is the surface, the area of the surface for this top and the bottom. And now the side here. So now we have this side. So what is the area of this side? So this is y multiplied by z. You have y there. So you have y here and this one is z. So yz. And because of you have 2 surface area side, so this is another side, right? So plus 2yz. And then now you have something in front here. So let's say I put orange. So you have So you have this one. So this is your surface. And because the size behind there also the same, this one. So how can you get that formula? So that one is belongs to, so we have z and x. Okay, so you have plus 2x z. So that is the formula of the surface area. You've got 6 surfaces, right, for to obtain the cuboid. So we have this formula. Okay, sorry. So now we want to get, so maximum error. Maximum error means you have to have the true change of the surface area. So that is the thing that you are looking for, right? But then you want to approximate this by using total differential. You have ds. Okay, and since the question is asking for about maximum, so we have to put the absolute sign. So now we want to work on this one, ds. Why we put ds? Because you have a surface area now. So now we know that your surface area is a function in terms of x, y, and z. Okay, so now we want to work on ds. So what is the formula of ds? ds is equal to s, the partial derivative with respect to x, dx plus sy dy plus z dz. Okay, so that is the formula of total differential that you can see this from the previous videos. Okay, and then don't forget, because the question asking for maximum, then you can put the absolute sign straight away. So this is very important. Okay, so now you want to get the partial derivatives of the s with respect to x, y, and z. Okay, so now we want to obtain okay, first sx, differentiate the s here with respect to x. Okay, so you have x there, so differentiate x, you got 1, so you have 2y. So 2y, and you can't see the x here, so these are all constants, so it got 0, we will get 0. And this one, we can just see x here, differentiate x, you got 1, so you have 2z plus 2z. Okay, now sy. So differentiate the s with respect to y, so the y here becomes 1, so you have 2x plus, and you can see also y here, so it's become 2z, and this one 0, because you can't see the y, so all here for this one, these are constant, so when you differentiate constant, you got 0. And then sz, so you can't see the z here, so this 0, and this one z becomes 1, so you have 2y plus z here becomes 1, so you have 2x. So that is your partial derivatives. And then you plug in your result here. So you have 2y plus 2z. So what is your dx? You got 5 just now, right? Sy, you have 2x plus 2z, and also 5 plus 2y plus 2x multiplied by 5. Okay, so when you simplify, you can have 10y plus z plus 10x plus z, 10y plus x. Okay, so now y plus z, y plus z, y plus z, you will get 320. So 10, 320. And you remember, because you have absolute sign, then you have to evaluate for each term. So you have to split them. Then plus 10, x plus z, x plus z, x plus z, you got 300. That's for the second term. And then 10, y plus x, you got 220. Okay. And also separate, you have to evaluate for each of the terms, and you put the absolute sign for each of the term. So once you do that, you have to change this one to be smaller than and equal to. Okay, so now what you have to do is, if you can see it is negative, if, okay, for example, you evaluate and you got negative, then you have to make it positive. But in this case, there is no different, okay, because all the answer here, they are all positive. Okay, but okay, let's say, okay, now we just proceed with what we have here. So we have this one becomes positive too. So we have this plus 2000 plus 200. Okay, and then when you total up your answer here, you get for 8400 millimeter surface area, so it should be square, right? So this is your maximum error of the surface area for the cuboid. Okay, but then you see now your answer here is in terms of inequality. So how can you explain in English? So the maximum error of the surface area is smaller than and equal to 8400. But look at your question here. Find the maximum error in the surface area. Okay, but then your answer here is inequality. So how can you answer that? So to answer that, you have to just make a conclusion. So therefore, okay, from the inequality, so you can see that. So therefore, the maximum percentage error. So you answer back the question. So the greatest error. Therefore, the greatest error in the surface area is what? If it is smaller than 8400 or 8400, so what is the maximum then? So the maximum is 8400 millimeter square. So meaning that you have to say it. You didn't, please don't just compute and then you just leave your answer just like this. So if you leave your answer just this one, so I don't understand. Okay, so please say something from what have you obtained. Okay, so you have to mention the maximum error is what. Okay. Okay, so let's say now, how about if when you do the calculation, so your answer here, for example, so let's say just like a quick example, the answer here will give you, so I erase this, for example, this one will give you negative 10 to, just a quick example, okay, I put 20. So when you multiply, and because we know that this one there is absolute, right? So this one is supposed to be always positive. So the answer becomes, so this is not the answer for this example. So this is become, originally it's become 200, right? Negative 200, but because you put the absolute sign, so it's become 200. Okay. So you just total up, so you got the answer. So that is the way that you have to do. But let's say some of you forgotten to just calculate each of the term, then you forgot to put the absolute sign. So let's say you just give me that. So can you see what happened if you forgot to put the absolute sign for each term? So you will assume that you will compute that it's become negative 200 and then you total. So the answer is not correct, right? Because this term should be positive. So be careful for solving this particular example. So this is common mistake done by your seniors, okay, my student before this. So please just don't waste your mark, okay? So please careful when you are answering the question. So please always take note on this, okay? Please take note on this thing. All right. Okay, that is the first question. You can see that there are two questions in the example in this particular question. So find the maximum error. So we done that, and the percentage error in the area. Okay, so they're not just asking us to get the maximum error, but also they want us to obtain the maximum. Okay, just percentage error. Find the percentage error. So what is the formula of percentage error? So percentage error is from the relative. So you have ds over s, and then multiply by 100%. So that is the formula. So there is no statement about the maximum, right? Just a percentage error. Okay, so that is our next task. So we're done for the first task, and we go to the next task. Number 2. So we have done finding the s just now. Okay, so in this case, no maximum. So no, just the s. So formula is sx dx plus sy dy plus sz dz. Okay, and then divided by the s. So divided by the s. So the s just now is what? Okay, 2xy plus 2xz plus 2yz. Then we have to evaluate this. Okay, so from the above, we already compute the sz dx, sy dy, sz dz. And because of all the terms, they are all positive. So from the previous answer, so this one, yeah, because I already modified this. So you have this, you have this, you have this. Okay, so you have 10. Y plus z just now is y plus z 320. So you will get 300 and 2200. Okay, 2200. So your answer is 84. So in this case, if without absolute sign, also you will get the similar answer, because from the question here, they are all in positive, right? They are all in positive. So if you just take away, you just ignore the absolute sign, the answer will be the same. So you got 8400 divided by, okay, so 2x multiply 2xy, so xy 200, 120 plus 2 xz 100 and 200 plus 2 yz 120, 200. Then when you evaluate that, you will get 8400 divided by 112,000. Okay, and that is relative. Okay, and then you have to, because it is a percentage, so you have to have the s over s multiplied by 100%. So this one should be multiplied by 100%, and this one 100%. So you will get 7.5%. Okay, so that is your second. Okay, find the percentage error or percentage change in the area caused by the errors in the individual measurement. So you know now by change all the measurement for 5 millimeters each, and the effect, okay, the effect or the output, okay, the effect of for the surface area is about 7.5%. Okay. Okay, now it looks like with a possible error. So they don't say that it is off. If they say that off by 5 meters, so we know that it is decreasing. So the value of each measurement here is decreasing by 5 millimeter. But this one is just like possible error. So that's why we put positive the dx here. The dx is positive 5. Okay.